Hi Year 11, today what we're doing is looking at function notation and piecewise functions. So you have all your syllabus dot points that this relates to, and our learning intentions today are to use the notation fx to identify the value of y associated with x for numerical values and algebraic expressions, and to interpret piecewise defined functions where the function is defined differently in parts of the domain. So with function notation, we have that since the value of y depends on the value of x, we say that y is a function of x. We write this using our function notation as y equals f of x, where x is our independent variable and y is our dependent variable. What we have is for different values of x, we can find values of f at x by substitution. You can substitute algebraic expressions as well as numbers into functions. So we have 4 examples here. Our first example, if f of x equals x squared plus 3x plus 1, find f of negative 2. So our first step, especially when you're doing the exercise questions, is to write out our function f of x equals x squared plus 3x plus 1. Now what we want to do is we want to replace all of our x's with negative 2 in order to find f of negative 2. So what we'll get is negative 2 squared plus 3 lots of negative 2 plus 1. Now, in order to solve f of negative 2, we can just put this into our calculator, and when we do so, we get negative 1. For example 2, we have if f of x equals x cubed minus x squared, we want to find the value of f of negative 1. So what we have is that f of x is equal to x cubed minus x squared. So we want to find f of negative 1. So we're going to replace all of our x's with negative 1 to have the f of negative 1 is equal to negative 1 cubed minus negative 1 squared. Now when we put this into our calculator, we therefore get the f of negative 1 is equal to negative 2. For example 3, this one's a little bit different. We want to find the values of x for which f of x equals 0, given that f of x equals x squared plus 3x minus 10. So what we're going to do here is we are going to let f of x equal 0. So what we have is our f of x, which equals our x squared plus 3x minus 10, and we're going to let that equal 0. From here, in order to solve for x and find the values of x, we are going to factorize. So our factors of negative 10 that add to give 3 are 5 and negative 2. So we'll get that x plus 5 times x minus 2 equals 0, meaning that our values of x are negative 5 and positive 2. Our final example on function notation is to find f of h plus 1, given fx equals 5x plus 4. So we have our function fx equals 5x plus 4. And what we are doing is we're finding f of h plus 1. Whoa, that one's far away. Meaning that we are replacing all of our x's with our expression h plus 1. So we'll have 5 lots of h plus 1 plus 4. We then want to expand our bracket here. So we'll have h plus 1 equals 5h plus 5 plus 4. This then gets us, by collecting like terms, that f of h plus 1 is equal to 5h plus 9. Now, the next thing that we're going to look at is our piecewise functions. So with our piecewise function, a piecewise function is what it sort of sounds like. It's pieces of a function. Pieces of a function, a function is made up of 2 or more different functions defined for different intervals in its domain. So it's pieces of a function, so multiple functions put together for a domain. What we have for our examples is we have that fx equals 3x plus 4 when x is greater than or equal to 2, and we have negative 2x when x is less than 2. And we're going to find f of 3, f of 2, f of 0, and f of negative 4. So the first thing we want to do is we want to find f of 3. Now we need to work out whether 3 is greater than or equal to 2 or it's less than 2. And what we have is that we are going to have that 3 is greater than or equal to 2. So because 3 is greater than or equal to 2, we're going to be using that top function of 3x plus 4. So to find f of 3, we're going to have 3 lots of our 3 plus 4, and this gives us the answer of 13. Now, for f of 2, what we have is we need to work out whether 2 is greater than or equal to 2 or less than 2. And we have that 2 is greater than or equal to 2. So what we will have is, again, using that top function of 3 lots of our x, which is 2 plus 4, and this is equal to 10. Our next one, we want to find f of 0. So 0 is less than 2. So because 0 is less than 2, we're going to use that bottom function of minus 2x. So we're going to have minus 2 lots of 0, which is equal to 0. Ooh, I got that wrong there. And then we have f of negative 4 is equal to, well, we need to look. Our negative 4 is less than 2, so we want to use that bottom function. So we're going to use f of negative 4 is negative 2 lots of negative 4, which is equal to positive, it's equal to positive 8. And finally, for example 6, we have g of x, which is the same as f of x. We can use g of x or f of x or d of x or whatever letter we want to use. It just helps us to find different functions. So we have that g of x is x squared when x is greater than 2. It is 2x minus 1 when minus 1 is less than or equal to x is less than or equal to 2. And it's 5 when x is less than minus 1. So we want to find out what g of 1 plus g of minus 2 minus g of 3 is. So we're going to find g of 1, g of minus 2, and g of 3, and then we're going to put them all in. So with g of 1, what we have is that 1 is not greater than 2. It's not less than negative 1. 1 is between minus 1 is less than 1 is less than 2. So since 1 is between those two, we'll have that g of 1 is equal to 2 lots of 1 minus 1, which equals 1. So we have that g of 1 is equal to 1. Next, what we're going to do is we're going to find g of negative 2. So g of negative 2, now negative 2 is less than negative 1. So negative 2 is less than negative 1. So we're going to use that last function there. And we're just told that when x is less than negative 1, it is equal to 5. So that means that g of negative 2 is equal to 5. Okay, and then we want to find g of 3, and what we have is that 3 is greater than 2. So because 3 is greater than 2, what we will have, sorry, I'm just fixing some highlighting, is that when x is greater than 2, we have x squared. So we'll have 3 squared, which equals 9. So we'll have that g of 3 is equal to 9. So therefore, we want to find g of 1 plus g of negative 2 plus g of 3. So this will equal, well, g of 1 is 1 plus our g of negative 2 is 5 minus our g of 3. Oops, I wrote that down wrong, didn't I? So it should have been minus our g of 3. And our g of 3 is 9. So then we just go, what's 1 plus 5 minus 9? It is minus 3.